Hello, my name is Taha Shafa, and I am handing in my lab titled Digital Sensors. I will begin by showing you the code for the first portion of the lab, where I create a code to count the encoder as it turns, as the motor spins, and this is the code pertaining to the switch. As you can see, when it's on, and when it reads a high value, it turns a print string on, and when it's a low value, or for any other value, it shows the print string off. This is my circuit, although it's a little hard to follow. This is the switch that turns either on or off. And this is my LCD screen. And you can see as I press the switch, it triggers it on, and now it's off again. Now I'm going to spin the motor so that you could see that as I spin the motor, the value here shifts. That's a little hard to spin with one hand, but there we go. So I'm spinning the motor, and the encoder count is changing. Now it went all the way to 64,000 bits because I turned it one way. If I turn it the other way, it'll go back to 0. And then you can see the encoder counting up from here. So that makes it a little easier to see that as I turn the motor to the right, the encoder count goes up. Now the next portion of the lab is to build this Jacobian matrix. So here I will make this the active, set as the active project, and I will run the program. Now you see the end effector turning really quickly. I'll show you the code so that you can follow along with what's actually happening. There we go. So I took this from the previous code that we did a couple weeks ago, the min and max values, and then here's the code itself. I have the angle, the increment, and the velocity, and it starts thetas 1 and theta 2 at 0, and it moves it at a velocity of 100. So again, with a delay of only 10 milliseconds. So again, I'm going to show you what that looks like when I run the program. I run the program. It starts at 0, and it moves all the way to the other side, the other x direction in 180 degrees. Now I'm going to do the same thing, but I will change theta 2 to read 140. Excuse this. I'll run the program. Now you can see that theta 2 starts at 140. And it does the 180 degree rotation, but since the theta is at 140 and it travels less of a distance, it does not travel nearly as fast. So that shows that by changing the angle, you can change, it actually affects the end effector even if you don't change the velocity. And now we can do something like take it back to 0, change the velocity to 10 as it was previously, or let's make it just like 50. Run the program, and we can just experiment with different combinations of velocities and angles. So right there it starts at 50, and it's moving at a much slower pace, but nonetheless it is moving at a slower velocity because I changed the velocity to be 10 instead of 100. So that is the lab, the first lab of the second section of this course regarding digital sensors and the Jacobian matrix.